Question 6 says, in the diagram below, A and B are the x-intercepts of the graph of f of x. A straight line G through A cuts f at C. So we have that point over here. And we also have that G, a straight line G through A cuts f at C and the y-axis at 0 and 1. So we also given that point and that point. M is a point on F and N is a point on G such that MN is parallel to the y-axis. So we have MN over here and MN cuts the x-axis at T. There we go. Show that g of x is equals to x plus 1. So this is the line of G and we need to find its equation. So we can find its equation using the formula y is equals to mx plus c. But we need to know what the gradient is first, and we also need a coordinate. So here we're given 2 points. We're given first the x-axis, the y-intercept, which is having coordinates 0 and 1, and we're also given the point C. Those are the 2 coordinates on our line that allow us to calculate our gradient. So in this case, our gradient will be equal to 5, or we can say first y2 minus y1 is equals to, over x2 minus x1 will be equal to 5 minus 1 over 4 minus 0. This gives us 4 over 4, which is 1. Then this is now our gradient. Now we need to find the value of C. Finding the value of C, you can either do it one of 2 ways, inductively or by calculation. So just by looking at our graph and looking at the information given to us, they tell us that G cuts the y-axis at that coordinate. And what do we know about C? C represents the y-intercept. So if we already have the value, we don't need to make any unnecessary calculations. Just by induction, we can tell that C will be equal to 1. And we can therefore write our equation as y is equals to m, which is 1, x plus c, which is 1. And therefore you've shown that g of x is equals to x plus 1.